Okay, so let's try to solve this problem numbers 1025 divisor game. So the problem says that Alice and Bob take turns playing a game with Alice starting first. Initially, there is a number n on the chalkboard. On each player's turn, that player makes a move consisting of choosing any x with 0 x greater than 0 x less than n and n modulo x equal to 0. So whatever the number they are selecting, so that should be that we can divide n, okay, and x should be greater than 0, okay, replacing the number on the chalkboard with n minus x, and whatever the options we have selected, whatever the number we have selected, we can update the board by subtracting the value, right? Also, if a player cannot make a move, they lose the game. Okay, return true if and only if Alice wins the game, assuming both players play optimally. Okay, so input has been given n is equal to true, so it's true. Alice loses one, Bob has no more moves. Okay, and n is equal to 3, so Alice chooses 1, Bob chooses 1, and Alice has no more moves. So basically, if the number is 1, right, so whoever is playing first, so he will lose the game, okay, because there is no option and we have to select a number which is greater than equal to 0, okay. So the problem say that there are two players, okay, Alice and Bob. Okay, Alice approaches first. So see the first player, okay, and they always try to play optimally, in the sense like they will select a divisor such that it will put the opponent into a losing position, okay, and there is a number given in, okay, and they will select a divisor x such that x is greater than 0, okay. Once they have taken their turn, so they will update the board with n minus x, and once the game is over, we need to find out that whether Alice can win the game or not, okay. So let's take an example over here. So it is board, then the divisors, which are the divisors over here, it's the player, um, player, and then winner. Okay, so one, so board, let's example like a1 is given, okay, and it is given to Alice. So now there is no divisor, so basically Alice will lose the game, so and winner will be Bob, okay. Now example 2, okay, so we have taken 2 over in the board, okay. So now what is the divisor of 2? So which is which is the what is the divisor of 2? So it is 1 only, right? 1 can only divide 2, okay, and which is greater than equal to 0. So in that case, what Alice always tries to play optimally, right? So she will select 1 over here, okay, and so it is the player Alice, okay, and on the next turns it will update the board with 1. Now in the case like 1 does not have a divisor, so in the case like Bob, it will be the Bob's turn, and winner will be, now Bob does not have anything to select, so Bob will lose the game. So here winner is Alice only, okay. Next example 3, okay. Now 3 has a divisor as 1 only, okay, and it's the Alice's turn, okay. Alice will take the turn, and okay, and it will update the board with 2, okay, and there is for 2 on the divisor is only 1, okay, it's the Bob's turn, okay. Now she will what Bob will do is she will update the board with 1, okay, and for 1, right, there is no divisor, right, there is no divisor. So you already check like 1 is a losing position, whoever fix it, okay. So Alice, 1 will be given to Alice, okay, and basically she loses the game, okay. So here winner would be Bob only, okay. And you can see like 1 we already calculated over here, so 1 whether it's winning position we have calculated over here, 2 is a winning position or not, we have calculated over here. Okay, now let's take another example. Example 4. Okay, now for 4, what is the divisors? So over here 1 comma 2. Okay, and it is given to Alice. Okay, now what Alice will take, whether he will select 1 or 2. So that so if she selects 1, right, so it will put 3 to Bob. It will put 3 to Bob. Now 3, we have seen like 3 is a losing position basically. Okay, so but if she takes 2, 2 is a winning position. So basically as she tries to play optimally, so she will take 1 over here. Okay, she will not take 2 because 2 is a winning position, no? So if 2 is, if she gives to Bob, Bob will win the game and she will lose. Okay, so she will not give 2, she will not take 2, so she will take 1 only, so that it will be 3 will be given to Bob and Bob will finally lose the game, because 3 we have seen that is like a losing position over here. 3 is a losing position over here. Okay, so what she will take, so she will take 1. Okay, and so she will take 1 over here, she will take 1 over here, and finally the board will be updated with 3. Okay, and it will be given to Bob. Okay, now Bob will have one options like 3 will be only one option like to select 1, and it will be given to Bob. Okay, again Bob will I mean she does not have any choice other than 1, right? So second she has to select 1 only. Okay, she will select 1 and it will be given to Alice. So and it will 2 will be given to Alice. Okay, and 2 has a divisor 1. Okay, and we have seen like Alice 2 is a winning position, right? So Alice will win the game. So but let's check over here. So again, like it will be given to 1 over here. 1 does not have a divisor, so it will be given to Bob, and then Alice is the winner of the game. Okay, so if you mark the positions from 4 to 1, so 4 was the winning position, right? So you can mark as true, and then 3 was the losing position, so you can mark as false. 2 was the winning position, so you can mark as true. 1 was the losing position, so you can mark as false. So so from the 4, so when 4 was given to Alice, right? So when 4 was given to Alice, how did he get like it was a winning position? Because 3 uh, from 4 3 was given to Bob, right? So Alice took a divisor of 1 and 3 was given to Bob, and 3 is a losing position for Bob. So that's why Alice was the winner. Similarly, when 3 was given to Alice, 2 was given to Bob, 2 is the winning position. So Alice lost the game. Okay. Similarly, for when 2 was given to Alice, uh, 2 was the winning position because 1 was the losing position. So we can say, so if a move, if a move from the um, current position puts opponent into a losing position, then it's a winning position, right? So over here, if 4 is given to Alice, 4 is given to Alice, then we need to find, then we need to find, we need to find 4 minus 1 is a losing position or not. Now if 4 minus 1, which is 3, if 4 minus 3 is a losing position, then 3, then 4 is the winning position, right? Now how did you get like 3 was the losing position? Because you pre-computed, right? So, and when there is a pre-computation or pre-calculation involved, then we can think of approaching with dynamic programming. So we can have a DP array of size n plus 1 initialize with false. Okay, we already know like DP whoever gets 1, so he is the loser, he loses the game, right? So over here DP1 is we can mark as false. Okay, now what we'll do, like we'll run a loop from for I is equal to 2, I less than n, less than is equal to n, I plus plus, and another loop will run for j is equal to, sorry, j is equal to 1, j less than I, j plus plus, and if j I modulo j equal to 0, so if j is the divisor of I, and we pre-computed the previous position, whether it was a losing position, winning position. So in that case, if dp of I minus j, so if it is a losing position, then it's a winning position for the current player, right? So in that case, dp of I is the winning position or current position, as we can mark as true. Mark as true, and then we can simply break out of the loop. Okay, and if we return dp of n, then we'll get the results. Now what will be the time complexity for this solution? So time complexity would be to O of n square, because you are running 2 loops over here. Space complexity would be O of n, because you are using a 1D array, right, of size n. Okay, okay, so that's about it. Now can we still improve the solution? So this is a kind of a game theory problem. Okay, and we can see over a pattern over here, right? So one was the losing position, one was the losing position, 2 was the winning position, 3 was the again losing position, 4 was the winning position. So over here, like you can see, like if the number is odd, like 1 was odd, 3 was odd, so if number is odd, then it's a winning, it's a losing position. If the number is even, in case of 4 and 2, it was a losing position, it was in winning position, right? So if the number is odd, we can say like it's a losing position. If the number is even, then it's a winning position. So in that case, we can simply return, right, whether the number which was given to play. So you can simply return like so you can think of the optimized way. So if the number modulo 2 equal to 0, then you can simply return true, just a one liner. Okay, and in this case, like time complexity would be O of 1 and space complexity would be O of 1, because you are not using any extra space, and this is just a one liner. Okay, but it is just to, after seeing the pattern over here, like right, so 1 was the one, when 1 was given, it was a losing, 4 was a winning position, 3 was a losing position, 2 was the winning position. So there is a pattern, like when there is a number is even, it's a winning position, when the number is odd, it's a losing position, whoever gets it.